So it gives me great honor to, I got to talk to one of my friends earlier today when Katie Chong was talking, and I get the opportunity again to introduce a good friend of mine, Tom Llewelyn, who works in the SysDig UK team, and today he's going to be talking about cloud native security with Falco. So Tom, over to you.
Okay, going straight into it. Yeah, let me just share my screen in that case. Let's hit that and present. So are we sharing successfully? All good to go. Good. Right. Good. Excellent. So yes, thanks for the intro, Chris. As Chris mentioned, so I work alongside Chris in SysDig. And the focus today is going to be on the Falco project, which is one of the open source projects that was originated in SysDig, but we donated it to CNCF, and it's now very much a CNCF run project that we still contribute heavily to. And Falco is very much focused on runtime security in the cloud native space. So we'll delve into, essentially, this is an introduction to Falco, what it is, what it does, how you can use it, how you can get involved with it. I will speak a little bit at the end, just a bit of a plug, since we're sponsoring the event, just to tell you a bit more about what SysDig does as well in using Falco. But the bulk of the talk will be on the open source aspect of it. Starting, taking a step back and thinking about approaches to securing systems, though. So fundamentally, there are two things you can do. There's the prevention side of things, where you're actually trying to modify the behavior of a system by stopping things from happening. So, it could be killing processes, it could be just blocking system calls, the actual doing things on the system. The other aspect is detection, where you're looking at what's happening live on a system and then looking to detect things that look suspicious. So, it could be a process suddenly starts talking to a new network or accessing files and modifying binaries, those sorts of strange behaviors, and picking up on those two. And they're two different approaches, and you need both in a system. So you'll need prevention style systems, guardrails and so on. You also need detection capabilities within your systems as well, because the prevention is only as good as the rules you've thought of. Detecting when there is suspicious behavior is a much harder thing to do, but it's also one of the key things that you need to do to find where you have zero-day exploits or possible malicious actors within an environment. Often the only way you'll detect those is by looking for suspicious behavior. So just looking at a few examples of tooling within this, the Linux world that deals with these kind of security enforcement capabilities. You have things like SEComp and SEComp BPF, which are involved in filtering system calls, so you're actually blocking system calls. SELinux, which is very much a Linux security suite, and it's vastly capable in terms of doing mandatory access control and label-based security profiles and so on. AppArmor, a similar sort of thing, but takes more of an application wrapper approach. And then things like IP tables, firewalling. So that all of these tools are there to kind of try and lock things down, to, as I say, put guardrails around your workloads, prevent them from doing suspicious things, prevent them from accessing things they shouldn't. And you need all of this stuff, but it's quite difficult to get it correct. And as we add more layers of complexity, as we add Kubernetes and container runtimes and so on, and dynamic workloads, getting that balance right of blocking stuff and securing things whilst also enabling those workloads to do what they're supposed to do, and not slowing down your developers, not slowing down, not getting in the way, is a difficult thing to do. And then looking at on the detection side of things, we have things like the kernel audit D. And if you look at what SELinux does, it actually sort of sends audit events at the point where it detects denials, but they're just that sort of auditing what's happening live on your system, just getting that audit log out. Kubernetes also has an audit logging system. And Falco, which is what we're going to talk about predominantly today, fits into that detection side of the security. So Falco itself doesn't do anything in terms of prevention. It's very much taking a stream of data and looking for anomalous activity within that stream. As you can see from there, though, you know, the list of tools that do this kind of detection, there's a lot to be done in this space. And, you know, we're working inside Sysdig on a lot of things like, you know, machine learning capabilities to be able to piece together the anatomy of an attack across multiple steps. So, you know, if you see this behavior followed by this behavior, and then, you know, this could be an escalation followed by a lateral movement, those sorts of attack vectors, we're trying to piece that together, and from a detection point of view becomes extremely important. As you see on the bottom of the slide there, you can't rely just on prevention. So assuming that you've put all the prevention in place and that you're done is never enough. You need the detection rules in there as well. And yeah, just as an analogy to that, you know, I've locked all my doors, but what if somebody, you know, if I leave one open, or if somebody manages to break a window, then if I've got a dog in my house, then that dog can alert me to what's going on. So that's, you know, so it's the two that you need. Both are useful. You're not going to rely on your dog to secure your house, but you can, you know, you can use one to detect what's going on. You get the idea. So moving on to Falco and what it does. So the first aspect that Falco deals with is the system call stream coming from the Linux kernel. And the reason that this was chosen as an information source is because it's fundamental to everything that's happening on a Linux system. So if you look at trying to secure a container workload on running in Kubernetes on a host, there's a whole lot of layers there. But fundamentally, you've got a process that's running on a Linux kernel. And in order to interact with the outside world, it has to make system calls. And so that system call stream is going to tell us an awful lot about what's going on in that host and what that process is up to. And so then by starting from that kernel system call, we can see, you know, what processes are running, what IO there is going on there, what network they're accessing, and so on. And, you know, there's a complete picture that you can build up just from that system call stream. So it's an extremely rich source. And this was one of the fundamental things that Sysdig started out doing, was tapping into that system call stream and making sense of it and tagging that data with all the kind of the layers, or as you build up. So, you know, this is a process, it's running in a container, that container is running as part in this pod, which is part of this deployment, which is in this namespace, all of that sort of complete layering up. But fundamentally, if you've got that system call, that's where we start from. And so one of the things that Falco is able to do is instrument at that kernel level. And it does this in two ways. So you can either insert a kernel module, and we've open sourced this kernel module as well. So you can then insert that into your kernel. That enables a ring buffer that exposes that system call stream into user space, which is then fed into Falco. Or conversely, for more modern kernels where we have eBPF, which is where we'll be moving in future, is using an eBPF probe, which then gives us that standard interface. So rather than having to insert modules into your kernel, you can just pull that same data stream out of the kernel. Either way, we're getting the full system call stream and then feeding it into Falco. And then you've got a couple of libraries in there, so libscap and libsinsp, which are the analysis libraries that then will categorize and structure that data as it comes out. And then we will have a rule set that you can give to Falco, which you can then use to spot particular behaviors. So it's pattern matching essentially against that data stream within that. The second source that we're able to ingest with Sysdig, with Falco, is the Kubernetes audit logs. So this is a standard API that's coming, a standard feature of the Kubernetes control plane now, where all security relevant data is being dumped out of this stream in chronological order. And so we can see all of the activity generated by users, applications, etc. So all API interactions that are security relevant will be passed out of that Kubernetes API. So the API log. So essentially, this is stuff that is manipulating etcd, which is where the fundamental state of your Kubernetes cluster is being stored. That's going through kube API to as the front end to that, and then all manipulations that are going into that come out of that audit log. And again, so this is now a very rich data stream of all deployments that are happening, any edits to objects, config maps, creation of secrets, anything that's being deleted, all of those sort of security relevant data is all included in that audit log, and is being and can be fed out to Falco so that it can ingest it. And then finally, this is a fairly new capability that we've added recently, where Falco is now starting to be able to ingest cloud logs. So AWS CloudTrail was the first one, where we have all of the audit logs from your AWS cloud accounts. So this could be things like creating ELBs, exposing S3 buckets, IAM role creation, etc. Users logging into your account, and then what do they do when they log in? All of that kind of low-level cloud account activity is a new data stream that we can ingest. So AWS is there, GCP is coming, and Azure very shortly, and I believe GCP may already be released. And again, what this gives us is yet another data source that you can ingest with Falco, and then look for suspicious anomalous behavior in terms of what's being deployed into your AWS account, what edits are being made to the resources within that. Are people manipulating policies? Are they deleting logs? All of that sort of stuff that you can then look again for writing rules against, trying to spot anomalous behavior. So bringing this all back together in terms of the Falco architecture. So you can see that if we go kind of bottom left upwards, so we've got data being ingested into a Falco instance. So that could be from the kernel on the host where you've got Falco running, or it could be external data sources coming in via HTTP, via REST APIs, so the cloud audit logs or Kubernetes audit logs, which are being fed into those that ingestion service that's then categorizing that data and making it usable. And that's then fed into the filter expressions, which are built from the Falco rules. So the Falco rules get loaded in at start time that essentially determine your runtime policy. And then essentially we're looking for pattern matches of my policy against the event stream. And then when we detect, when a policy triggers, a rule triggers because the conditions have been met in that data stream, we can then trigger an alert. And so this is why, so Falco is very much on the alerting side of and detection of that security structure. And then alerting can feed to a number of outputs. So it could go to syslog files, shell, or gRPC. There's a very good open source project called Falco Sidekick, which we'll talk a bit more about, which you can ingest Falco, and then that has integrations with all sorts of third-party capabilities. And you can also do things like create Prometheus metrics. You can sort of, push out metrics from it. So in terms of where you push that, all of this, then the alerting from Falco can then act as the start point for either a response event or some sort of remediation workflow you could trigger, or whatever it is. But essentially, Falco is very much there for this detection of the anomaly, and then hook into something else, which will then take care of what happens next. So fundamentally, Falco rules are just YAML. And so you can see there's an example Falco rule on the screen here. And the rules can be, so the rule set can be made up of macros and lists and so on. So you can create a macro and then call that macro within another rule and so on. So you can see in this rule here, rule file here, we've got a few macros being created. So looking for things that are a container, looking for things, writing to FIFOs and so on. So, and each of these macros has a condition. So that's what are we looking for in the pattern match? And one of them is looking for a container ID. Other conditions are looking at the process command line. And then here we've got our full rule for container drift detection. So this is essentially, it's an event type is open or create, and the open exec is true. It's a container. It's not writing to a FIFO, and it's not writing to valid Docker, and the raw res is greater than or equal to 0. So then essentially this is, can we spot a new file being opened, so a new binary essentially created within a container. And if I click on this, hopefully this will switch me into a nice pre-record of this. So I decided not to anger the demo gods and try and actually do a live demo. But this will play us a nice little execution of that rule that we just saw. So essentially, we already have the rule. So Falco comes with a default rule set, which is quite large and complex. So for this demo, it's just been cut down to just that single YAML rule that we have in our capability, so that we can just run Falco with that rule, and then create a container and trigger the detection of our suspicious behavior. So let's run Falco. And we can see that, there we go, we've created a Falco instance that's now there and running. And now we're going to spin up a container. And within that container, we're then going to create a new executable file and then try running it. So created a file, created a container. We're now running in the shell inside the container. And my colleague that developed this forgot that he doesn't have Vim inside his container. So yeah, he has a couple of aborted attempts to create the file. Then he realizes what he's doing. So yeah, so he's creating a simple C program that is literally just going to generate a binary that opens a file. So drop the code in, so you can see what it's doing is opening a file. And then we compile that and then run a.out, the output of the compiler. And you can see straight away when that executable ran inside the container, it's now triggered my rule in Falco, and I've got that detection as which has got the variable substitution in it. So you've got the context of what was going on. And so, so it's pretty simple. So this is just, single standalone Falco local container running on its own. But, in terms of that's, sort of my first Falco rule. But you get the idea of, this is fairly simple. When, it's the classic thing of try and do one thing well, which is what Falco aims to do, which is that detection piece, giving you that rich capability of starting from a very fundamental information source and building up from there. In terms of then developing policy and having rules to do things, as I say, Falco comes with a default rule set, which gives you quite a lot of additional rules, not just the one we saw there. There's also the Cloud Native Security Hub, which is a Sysdig sponsored website where we have policy being developed. And so on there, you can go in and look for specific use cases and find Falco rules amongst other things. And you can see, there's things there for Fluent, Elastic, and so on. There's also quite often when a new CVE, a critical CVE is discovered that has a large impact, there will be a blog post written by somebody at Sysdig who then will develop a specific Falco rule to detect the exploit of that CVE. And then that will be pushed out to this as well. So, with this over time, this resource should be building up. But you can contribute to this as well. So you see, on the site, there is the ability to send your own rule suggestions if you want to, so that you can help the community build up this database of capability in applying Falco. Installing it is fairly straightforward. So Debian or Red Hat systems, there are RPMs and D packages available, so you can just apt-get or yum install it. If your distro doesn't have those available, then you can just run a shell script that will pull down the latest binary and install it for you into locally. And finally, you can run it as a Docker container as well. So you can just pull the Falco Security Falco image, and there's full instructions on how to install it and run it, and just play around with it on that on the falco.org website. If you want to install it onto Kubernetes, then we also have Helm charts available. Or you can just go and grab the daemon set and apply that directly. So depending on which you prefer. But again, so running Falco as a systemd process gets you a better isolation, and means you're running low level on the host outside of the container runtimes. Actually, when it comes to Kubernetes, you can then just deploy it out as a daemon set onto the Kubernetes cluster. That daemon set will require privileged access, of course, because it still needs to hook into the kernel on the host. So it's going to require that root level access to do that. And then in terms of additional things, so this is just this slide deck will hopefully be made available, but there's a whole load of additional tools that you can use to then help you manage and create and deploy Falco into your environment. So Falco CTL for just controlling things, Sidekick, as I mentioned earlier. So this has got a whole load of integrations into third-party things. So once you've triggered a rule, you can pass it into Sidekick, and that can integrate into various other workflows, so that you can sort of, trigger it, other things, and then other clients and so on. Also a Prometheus exporter, which can be very useful in terms of then if you're using Prometheus as your monitoring tool, as your monitoring framework, then you can feed those events into Prometheus as well and start dashboarding it and so on. So yeah, just a quick mention of Sidekick. So this is a community contribution. It came from somebody not connected with Syscalls at all, who's developed this as a way to integrate Falco into things like Slack, Elastic. You can see there's a whole load of lists of integrations on there. So it's extremely powerful and capable. And yeah, there's a growing list of that because it's got a nice architecture for adding these integrations into. So that's extremely useful. And you can see that, yeah, just the explanation of what that that Sidekick capability is going to do is actually then take the events out of Falco and publish them into an SNS topic or a Teams channel or whatever else you want to push that event to. And that could then have additional workflows triggered from that event. So that could be execute a reaction like killing the offending pod or so on, and also send on additional notifications elsewhere. So it's a first step to building that enterprise level security capability, if you want to build one by yourself. Another thing you can do, so CM, so the security information and event management. So there's a number of products out there available for doing this kind of event management, where you essentially they'll all ingest a stream of events from various sources and then hope to correlate events and respond to things when you have a security breach. If you're looking to do that building with your own open source stack, then you can use EFK for that. So you can push the events out of Falco and then use that to construct your own SIEM. So if you are, of a build it yourself bent, then please do that. And then you can see that, yeah, you can start looking at generating nice charts and pictures of what's going on and what rules are being triggered, so that you can then start seeing threat maps of what's happening live on your systems and so on, and what's going on over time. And there's a whole load of resource out there. So again, there's a whole lot of links here that we will be able to provide you with after the event, talking about the various technologies that Falco is built on, things about eBPF and so on, and various other sources of information around Falco. It is a growing project in terms of both usage and contribution, and the momentum that it has is growing. So please, if you want to get involved, there are a number of ways you can contribute. So Falco Rules, as I mentioned, that we have that security hub where we're always looking for new use cases. So if you start using Falco, you develop something yourself and you think it's useful to the community, please contribute it back. If you have a new integration that you'd like to see in Sidekick, well, you're free to develop it yourself and contribute it back as well. And then we're always looking for additional use cases, workflows, third-party integrations, documentation, and so on. So it's if you would like to contribute, then there will always be plenty for you to do. So please contact the project maintainers, and they'll be happy to give you something to do. So how are we doing for time? Yeah, just a few minutes left. So just a quick word about, so I work for Syscalls, as does Chris, and while we're the originators of Falco, it's now CNCF, but we still use it heavily within what we do. So we start with Falco as the foundation for Sysdig Secure, where we're using it embedded into the Sysdig agent. But we're using exactly the same three information sources we've just been through. So the system calls, the Kubernetes audit logs, and the cloud runtime audit logs. And what we do from that is we build up from there to create a secure DevOps platform. So most of what I've been telling you about, the third-party integrations and building your own SIEM and all of that, well, all of that integration work and that policy management work comes out of the box with Sysdig Secure. And we also add in additional capabilities like image scanning for vulnerabilities and misconfiguration, cloud compliance from a static point of view. So, things like CIS benchmarks and compliance standards for your cloud accounts and for your workload platforms. And then in terms of what we do with Falco, we enhance the capability of it. So the policy management is centralized in a Sysdig backend, which you can access via web UI or API. It can also take interventions like kill, stop, pause containers and so on. And then we also have integrated incident response. So we can trigger captures from Falco rules as well, which is another Sysdig technology, which builds on the same capability, where we're just essentially dumping out that capture file that's generated by the Sysdig runtime to then do post-event forensic analysis. So if you're looking to adopt cloud native security within an organization, you have the option of building it yourself. We'd argue that possibly your time might be better spent actually furthering your business, and that Sysdig will give you a whole lot of stuff out of the box that you then don't have to build yourself. But it's building on that same open source capability to run all of that. So with that, I think that will cover all I wanted to today. I mean, there's a whole lot of features in there in terms of what Sysdig has. I'd be happy to talk about that at length. But at that point, I just open up and see, do we have any questions?
I don't see any questions on Slack or in YouTube, but folks are online. Please feel free to ask questions in either of those portals. As Tom had just there, if you're watching this on the replay, you can also ask questions in the Falco Slack channel, which is over on the Kubernetes Slack group rather than the CNCF one. Yeah, thank you very much, Tom. That was a great presentation. Josh, I'm not sure if you've got anything else to add to that.
No, that was fantastic. Thanks very much, Tom. In that case, that's the end of of this track for today. Just a reminder that we will be back tomorrow. So follow us on Twitter, keep on the lookout. Head over to kcduk.io for all the information. If you want to head over to the Track 1 YouTube, I will post the link in the YouTube chat. You can also find it again on kcduk.io. We'll be finishing off Ann Curry's talk on Kubernetes is doomed. And then we'll be kicking off with the pub quiz. So we'd love to have all of you over there to join us for that. But thank you very much. And that's Chris and I out for today, I think.
Pub quiz should be a lot of fun. So do stick around for that. And thank you very much, everyone, for taking the time and energy to stay tuned. I hope it's been a good day for you. It's certainly been a lot of fun for us. Cheers, folks.
Thanks all.